Hi everyone, let's talk about some solar geometry and sunbeam diagrams. You've already learned about the path of the sun, how it rises in the east and sets in the west. And you've taken a look at some basic solar geometry and learned about azimuth and altitude. Let's take a look, all right? And when the sun rises here on the horizon, this circle indicates the horizon. Right? When the sun rises, it comes up in the sky all the way up until noon and then sets over towards the west. Right? You can describe the sun's position in the sky using two angles, altitude and azimuth. Altitude, see it right here, is the elevation of sun above the horizon, and it's an angle. Right? So in this example, excuse me, it is the angle between our flat ground right here, 0 degree elevation, and up until the angle of the sun in the sky. The other angle that we use to describe the sun's position is called the azimuth, right? And it's the horizontal angle, right, of the bearing of the sun in the sky. The picture on the left you see here is called a solar dome, and it's really a depiction of how we measure these different angles. And so you can see that altitude, all right, is the angle up in the sky, right? And you'll see each of these kind of hoops or rings indicate a different altitude, right? A different angle as they move up towards 90 degrees. And then azimuth is your horizontal angle. And so each one of these they look almost vertical pieces, all right, is measuring a different azimuth as you move around your central site. Right? Now, if you take a look at this solar dome and you look at it straight down, all right, so a horizontal projection, we look at it orthographically, you will see a series of circles. All right, we've got these circles, and these are kind of these hoops. All right, and we'll see the radiating lines. So these pieces here are going to look like straight lines radiating outward. The circles, all right, are going to show the altitude, the angle up in the sky, and the radiating lines will show the angle, all right, the azimuth, the horizontal angle. Once you plot all this information, it looks like this. This is called a sun path diagram, or more specifically, a horizontal sun path diagram, because there's another one for vertical. All right. And it is specific to a particular latitude. So the first thing you want to know is which latitude are we looking at? This example we have on the screen is for 40 degrees north latitude. Right? And on this diagram, you're going to see the concentric rings, just like we saw in the last slide. All right, those describe the altitude or the horizontal angle of the sun. And then we see the radial rings, these kind of hoop-like rings, and they're going to define the azimuth or the elevation of the sun in the sky. We also see sun paths, and they look like these big arcs, right? And if we slide back, right, these sun paths are just like in our three-dimensional sky dome here. The sun path, it's the path that the sun travels, all right, throughout a particular day. Moving back to our sun path diagram, each one of these sun paths describes a particular day. All right. And so for each one, the sun will rise in the east, come up and reach solar noon, and then come back to set over here at the west. Remember that the outer ring here is going to indicate our horizon. On this diagram, there is one sun path shown per month, all right, and they specifically pick the 21st of every month, but that's beside the point, all right. But we only see 7 paths on this diagram because our year is symmetrical, right? And this particular diagram has them shown with Roman numerals, all right? So you can see 12 here is for December. And I've labeled them. You'll see other publications will actually put the month on there. So you start the year here in January, all right, with this line. Moving up to February, March, April, May, June. All right, and then back down July, August, September, October, November, and here's our shortest month of the year, December, shortest day of the year. There's one more important piece of information, and that is the time of day. And you can see that printed up here with these numbers. These are our hours of the day. So starting over here at about 4:30 in the morning, 5 a.m., 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m. Here's noon, solar noon, right along this line. Right? 1, 2, 3, 4 in the afternoon, etc. This diagram helps us to find the altitude and azimuth, or the solar location, for any particular day of the year. For example, let's say we wanted to know the altitude of the sun at solar noon on the spring equinox. All right, so we'd take over here and we'd say that was March. Right, we know that we were on this line right here, right? And this is solar noon. So we're looking at this point right here. Okay, well, how do we find the elevation or the altitude? All right, it turns out that we read these radial rings, 0, 10, 20, 30, 40, 50, right there, 50 degrees. Let's try another one, and let's say we want to know the location of the sun at 3 p.m. in June, right? So we find the line for June, right? We come along here to 3 p.m. in the afternoon, very hot afternoon. And first let's find the elevation or the altitude. And so we can come over here and count 1, 2, 3, 4, almost to this 5th ring. All right. So sliding over, we can see that we're somewhere between 40 and 50, closer to 50. I'd probably call that a 47. All right. And you can interpolate. But what about the azimuth, all right, or the horizontal angle? Turns out you can read that straight on these radial lines, right? And so we can see that our point here is just about at this 80 degrees section. Although this diagram really helps us visualize altitude and azimuth and the sun path for the different times of year, you can also use a sun path calculator to find the same information. So let's take a look. Here on your screen is one of the best that I've found, the NOAA Solar Calculator. And what you do is you can either pick up and drag your pin to a specific location, or you can come down here and specifically enter latitude and longitude. So let's use the example of Harrisburg, Pennsylvania, and slide in. Let's go see if we can find it. There we go. All right, here we are in Harrisburg. All right. And sliding down, we can see that we are about latitude 40. All right. And you can pick a specific date or time. So for example, let's pick December 21st. All right. And let's pick noon. All right. And once you've entered all this information, you can come down here and check out the azimuth and elevation. They're using elevation instead of altitude. All right, it's the same thing. You see that the azimuth, they've got given 178, all right, and the elevation, all right, 26. Now make sure that you understand how they're measuring. So you can hit this little question mark button, all right. Azimuth is measured clockwise from true north to the point on the horizon directly below the object. Elevation is measured vertically from that point on the horizon up to the object. Right? So we have this information right here, and you can also click this little button here, slide down, and it will show the azimuth angle, right, directly on the screen. So that's for December 21st at noon. Let's look at a different date. Let's say March 21st at 3 p.m. All right. You can see immediately that we're getting that afternoon sun angle. You could slide down and find out the azimuth and elevation. Once you have the altitude and azimuth data and you've done some analysis and found out where the sun is coming from, all right, on some important days for your design, you can then take a look at your plan and section and find out when, all right, and how far the sun is going to penetrate into your building. So let's take a look at these sunbeam diagrams. First of all, let's take a look at the plan. On the plan, we're concerned with azimuth, all right, not altitude. We're concerned with azimuth. And so you can see that what we're interested in is the angle at which the sun penetrates into our building. So you would find this piece of the window right here, right? And this particular angle, that's our azimuth, and trace this ray right here. Do the same with the other side of our window. All right, you can see that this particular sunbeam, all right, is going to enter our building. Same with this window over here. Now it's going to be the same angle, all right, because the sun is coming in at the same angle, and we'll see that it penetrates into our building in this way. Taking a look at our building in section, all right, now we're interested in the azimuth. Taking a look at our building in section, now we're interested in the altitude or elevation angle. All right, so notice that it's a different angle. And we're going to come in and see where is our sunbeam going to penetrate in our building from here to here.